Today is day 2. Hi all, good morning, good evening. Welcome to the day 2 of our exclusive training, Generative AI in Software Testing, where we are learning how to leverage Gen AI in the field of functional testing as well as automation testing. I am Chandra, your trainer for this entire training. So yesterday we went through the different modules, like we understood basically the types of AI, right? And then what is these applications of AI and all. And then we went through the key concepts like machine learning, deep learning, natural language processing, generative AI, language models, etc. And then we also learned about the two types of language models. Who can tell me the different types of language models? Anyone? Who can tell me the different types of language models? Okay, someone has mentioned as LLM and SLM, I believe. So that is large language model and small language model. Yeah, very good. You have a question regarding the time change. So the time won't be changed. So I'm available during this time. So the training will happen during this time. Thank you. Okay. And then what is a token, guys? Anyone wants to unmute and say, or if you want, you can put the message in the chat. What is a token with respect to Gen AI? Anyone? What is a token? How many of you attended yesterday's session? Can you please raise your hand? So what is a token, everyone? Okay, I can see 2 hands raised. Some answer in the chat. So basically, whatever input, okay, you can lower your hands. Whatever input or instruction we are going to provide to the AI model, right? That input is broken down into smaller blocks, right? Distinct blocks. Those blocks can be a phrase, a word, or even a punctuation mark, right, everyone? Here or not? So that is how you can basically break down the process. Then what is tokenization, guys? What is tokenization? Anyone? What is tokenization? Background process for LLMs. Okay. So the process of breaking down your input, right? The process of breaking down your input to convert that into tokens or to break down that into tokens, that is known as the tokenization, right, everyone? All of you understood? That is the tokenization. So then we will basically see the next process. How do these LLMs work? So before I start for the day, anyone has any queries? Anyone has any queries from the previous session? No queries? Anyone? Any queries? Okay, Suresh, you have raised your hand. Do you have any query? Because I think previously you had raised your hand.
I'm sorry, I forgot to lower down. I'm good.
Okay, so let us start for the day. So let me start sharing my screen, everyone.
So I have just one query. I have just joined today as a new. So please share the video of previous session when you get a time.
Yes, yes, that will be shared. Are you part of the WhatsApp group?
Yes, yes, I'm the person.
So the recording is sent in the WhatsApp group. So probably I
Okay,
will again share after this session today. Okay. In case you would have joined late in the group, then I'll again share the link today. Okay.
okay.
So
Uh,
today is day
this
two.
is
However, we had two sessions already where we had the demo session and then we had the day one session yesterday and today is our day two. Okay.
okay. Fine, fine. Thank you.
Yeah. Do you have any other questions?
Are you sending in the email as well, or only on WhatsApp?
No, it is being sent in WhatsApp for now.
Okay, fine.
Yeah,
Okay, thank you.
sure. Okay, so let me start sharing my screen, everyone. I hope you all can see my screen.
Yes, it's visible.
Okay. So we had seen about how does AI understand us, where I had shown you the process of tokenization, right? Then we go to the next topic. How do LLMs work? So now our focus will be on large language models because small language models will be used for less set of training data, or you want to develop smaller applications, right? But LLMs will be primarily used by us. Okay. Now how do these LLMs work? Okay. Now remember, whenever we are providing any input, whenever we are providing any text, right? So these LLMs will try to understand the pattern between the words. So whenever we are providing the input, they will be broken down into tokens. So whatever text you are writing, the LLMs will try to understand the relationship between those words, those phrases. Okay. So this, I told you, the LLMs will be trained on large, huge data sets. So they will be, the data will be fed to them. Understood? Now, when the data is fed to them, these LLMs will understand the pattern, the grammar, as well as the semantics of the human language. Okay. So whatever data we feed them, nowadays the LLMs can also search through the internet, guys. Okay, the LLMs can search through the internet. So using this process, they can gather vast amount of knowledge. Yesterday I told you one term, knowledge cutoff. Who can explain me what is knowledge cutoff? What is knowledge cutoff? So when these LLMs are trained, they would be trained till a particular date. Now, if there is any event happening after that date, the LLM might not know the accurate information, right? So it has been trained till a particular date. So that is the knowledge cutoff date. Okay, that is the knowledge cutoff date for that particular AI model. Now, when they are, being trained on this data, they understand the pattern, they analyze the pattern, and they collect vast amount of knowledge. And based on that, they can predict the next word. Okay, so the LLMs will be able to predict the next word using the mathematical calculations and probability, guys. Okay, they will be able to predict the next word using the mathematical calculations and probability. Clear, everyone? Now, let's say I give you an example. All of you know the game cricket, right? Anyone is not aware of the game cricket? Anyone? Okay. So silence means I will consider that everyone is aware of cricket. Now let's say, guys, there is a discussion happening. Okay, there is a discussion happening between different people, between a group of people. And based on that discussion, an AI model has been trained from the results of that discussion. Okay. Now tell me some examples of batsmen, guys, good batsmen or great batsmen in the history of world cricket. Anyone? You all can unmute yourself and answer also.
We can say that Virat Kohli is the greatest batsman in the cricket. He scored very well.
Okay, I'm asking few names whom you consider are good batsmen. Now I'm not asking about the
Yeah.
great batsmen.
Okay, we
Okay,
can say
Sachin,
Sachin Tendulkar,
like Sachin Tendulkar, let's say. Okay, Brian Lara, right? Brian Lara, Sachin Tendulkar,
Kapil
Virender
Dev.
Sehwag probably, right?
Yes,
Saurav Ganguly.
Kapil
So
Dev also.
now let's say, guys, there is a discussion happening that between a group of people about some great batsmen, and whatever discussion is happening, based on that discussion, based on the information we are getting from that discussion, we are training one AI model. Okay. Now let's say there are a group of 100 people. 40 people, okay, 40 people mentioned the name of Brian Lara. 20 people mentioned the name of Virat Kohli. Another 20 mentioned the name of Sachin Tendulkar. And 10 people mentioned the name of, let's say, Saurav Ganguly. Okay. So 40 people Brian Lara, 20 Virat Kohli, another 20 Sachin Tendulkar, and another 10 Saurav Ganguly. Now, probably Sachin Tendulkar might be the greatest batsman, right? From if you see from different parameters. But because the discussion happened between a group of 100 people, and in that group of 100 people, 40 people told about Brian Lara, and based on that discussion, the AI model has been trained. So if you ask the AI model about this question, which question? The greatest batsman in cricket is that AI model, guys, which has been trained on that particular data set. What will be the answer? Brian Lara. Understood? Because it will do the prediction or it will generate the output based on mathematical calculations and probability. So, I'm sorry. So the data set with which we have trained the AI model, that is very, very important, guys. That is very, very important. Am I clear, everyone? All of you clear? So based on the statistical
So,
data,
so
based on the, tell me.
yes, sir, you can go on. I'm just a
Yeah,
little confusion, but you can go on. It's on statistical basis. Yeah, you can go on.
tell me your confusion. Your confusion needs to be cleared. Otherwise, if that confusion piles up, and then there could, in the
Yeah,
future topics, more confusion pile up. What is the question basically?
uh, yeah, can you repeat it again? 20 persons has given Brian Lala and 30% has
No,
given Sachin
40.
Tendulkar.
No, no.
Then,
I told 40.
okay,
I told 40 for Brian Lara. 40. 40
okay,
people.
okay, fine, fine.
40 people told Brian
Which
Lara.
is
20
highest?
told Virat Kohli. Sorry. The greatest
Yes, sir,
percentage
you can
basically, right?
continue.
The higher percent. Sorry, your voice is breaking. Probably can you please check your network? Okay. So based on this probability, the AI model will be able to answer the questions, or they will generate the output, or they will predict the next word. Now, guys, you see, because of this, what has happened? The data set on which you are training the AI model, it could give rise to incorrect answers also. Okay, it could give rise to incorrect answers also. Now, okay, same question, guys. If I ask, 100 people about who is the current president of the United States. Okay, I'm asking 100 people who is the current president of the United States, and let's say that sample of group of people, they are not very much aware about current affairs. They are do not they are not really catching up with the current affairs. Let's say maximum people told Joe Biden. Okay, maximum people tell the answer as Joe Biden, and out of that, what is happening? We are training the AI model, let's say, based on that data. And if I ask the AI model who is the current president of the United States, it will tell us the answer as Joe Biden. Understood? So the data set on which we are training the AI model, it basically gives rise to the answers. And sometimes, that is why sometimes what will happen, the AI model will exhibit bias. The response will be biased. It is not knowingly. It is not knowingly that it has generated the biases. Based on the training data, whatever we have trained the AI model on, based on the training data only, it has generated the bias. Bias means, you all understand, right? Showing some favoritism towards somebody. Now, because of the data set with which we have trained the AI model, it gave rise to bias. Now, there was one AI summit. Yesterday I was telling you, right? There was an AI summit in France recently, where our Prime Minister, Honorable Narendra Modi, had also attended that summit, right? Everyone. Over there, he was giving a speech on AI, and he started with, one discussion basically. He gave one example. If I ask AI, if I ask AI to generate the image of a person writing with left hand, all of you understand the point? Generate the image of a person writing with left hand. So what all are you expecting, guys? The answer or the output? What is your expected output? What do you expect? I'm not asking what is going to happen. What are you expecting from AI? When you are giving the instruction, generate the image of a person writing with left hand.
Probability of that person whoever had more.
No, I'm asking what is your expectation? What are you
Yeah, the
expecting
person
the AI
whoever
to generate?
got famous that got display.
No. I'm asking to AI generate the image of a person writing with left hand. Means I'm expecting that a image should be generated by AI of a person basically who is writing with left hand. That is the expectation, right? Let us see what happens. Generate the image of a person writing with left hand. What did you see, guys? What output are you seeing?
Image is created, but it is writing in by right hand, not left hand.
Very good. It is generating the images of the persons writing with right hand, not left hand. You know what, guys? This point was highlighted by our Prime Minister. I also didn't know this thing till then. Means about this, limitation. And this Grok, right? This is the AI model of X. Okay. Uh, Elon Musk, I think you all would have heard about him, right? So this is his product. Not only Grok, you go to many other, AI models, they will generate the image of person writing with right hand only. Because you know what? All the AI models have been trained with data and the general perception. What is the general perception, guys? The general perception is that people write with right hand. All of you agree? Very very few people would be writing with which hand? Left hand. Most of them write with right hand. That is what happened here, guys. The AI model exhibited bias. Okay, the AI model exhibited bias. It you know took for granted that okay, everyone writes with right hand, and it generated the images of people writing with right hand. So this is known as bias. All of you clear? It is giving you incorrect answer because it has been trained on that set of data where the answer which it is giving, it is based on that probability. Understood, everyone? So the probability to generate the text based on the data it was trained. So the data set on which it has been trained, based on that only, based on that probability only, the data is generated. So how do LLMs work and process our input? Okay, we discussed about they will do the prediction, but how do they process our input? How do they process our input? How do they get correct? Most of the times they will get correct, right? That is why we are using them. How do they get correct? So basically, there are two types of architecture, guys. There are two types of architecture. Initially, when this was, when this came into picture, we had serial processing. the AI models would process the input serially, one after the another. So they will predict, let's say, one word, then based on that, they will predict the next word, then based on that, then they will generate the next word. So this prediction and generation would work serially. Okay, it would work serially. But when there would be long sequence of data, there would be long sequence of data, it was very likely that when it is generating this particular text, it could have forgot the dependency of this text with, the previous text or previous words. It might remember with the, you know, very, those words which are just previous to it, but it could forget the dependency with, very distant words, right? So that is why serial processing was discarded. Serial processing was discarded, and then parallel processing came in. Parallel processing came in. So what was happening? The dependency between the different words would be intact, guys. So this word would track the dependency or with this one, with this one, and with this one. Similarly, this would track the dependency with this, and with this. Then this would again track the dependency with this word, and this word. This would again also track the dependency with the first one, then the second one, okay, and with this. So this becomes complex. Understood? This becomes complex, right? To have to link the dependencies, to keep a track of the dependencies of each word with the others. Understand? However, it becomes, faster. See, in serial processing, it becomes a bit clumsy. It becomes difficult to remember the dependencies. So to enhance this parallel processing, the very famous architecture was, came into picture, that is known as transformer architecture. Remember, guys, most of the LLMs, okay, most of the famous LLMs work on transformer architecture. This is another new term which we have learned today. Okay, transformer architecture. I'll explain the transformer architecture. What else did we learn today? Bias. This is another term which you need to remember, guys, with respect to Gen AI. Yesterday we had discussed about knowledge cutoff, right? Today I'm telling you about bias. Here, everyone, generating incorrect data based on the training data, right? That is bias. Here, another example of bias I'll give you. Regarding the airline crew, guys, okay? Let's say generate a text summary on the aircraft crew. I'm trying to show you something actually. Yeah. So all of you see here a flight attendant. So I asked the AI model to generate the summary on flight attendant. So here ChatGPT is a good AI model. So it has taken care of, you see guys, the word which it has, the pronouns which it has used. It has used as he or she, he or she. But some of the AI models, you will see that generally they will use this pronoun as he. Okay, they will they will use the pronoun as she, not he. They will use the pronoun as she, because the general perception is that the flight attendant carrier, you know, is normally pursued by the female gender. Understood, everyone? The flight attendant carrier is basically pursued by girls. That is a general perception. So if the AI models are trained on that particular data set, they will generate that kind of data, guys, the output. Now you see, yes. So for example, now you see nurse. Here the pronoun which it used is she only. So what does it mean? It is perceiving that, or it has a general perception that the nurse, right, is basically a carrier taken up by girls only. But nowadays you would see, guys, that in hospitals we have people who take care of patients and they are male. Understood, everyone? So this is also an example of bias. Did all of you understand what is bias or not? All of you? Any queries? Okay. Silence means I will take it as, people have understood all the points. Is there any message in the chat? No, right? So then we will go to the transformer architecture, everyone. We'll go to the transformer architecture. This is very, very important, guys. In transformer architecture, what happens is, this is the input. Okay, the input. You will provide the input, everyone. So input is nothing but the instruction which you are providing. Right now I gave like an input, right? Generate a summary on flight attendant, generate a summary on nurse, right? I was giving one instruction. So whatever input we are providing to the AI model, it could be one instruction, it could be a question. Understood? So that is basically known as a prompt, guys. The input is basically a prompt. Clear, everyone? And in this phase itself, what will happen? This prompt will be broken down into tokens. Okay, the prompt will be broken down into tokens, or basically the process is known as the tokenization process. Each token will be assigned a numeric ID, guys. Okay, each token will be assigned a numeric ID. Clear? Now, then once they are assigned, the next process will start, that is encoder. The next process will start, that is encoder. Now the encoder is basically responsible to understand the input. Understand everyone? The encoder is basically responsible to understand the input. And the decoder, we have another one known as decoder. The decoder is responsible for generating the output. Encoder will understand the input, decoder will generate the output. All of you clear? Now, this encoder has different components, that is embedding, positional encoding, and self-attention mechanism. Okay, now what is this embedding, guys? In the input process, what did I tell you? The prompt will be provided by the user. That prompt will be broken down into tokens, and then each token will be assigned one numeric ID, right? Then after the ID is assigned to the tokens, okay, we all of you would have heard about vectors, right? In mathematics, vectors. So we'll not go deep into this, guys, because I'm giving all this information for your knowledge. You need to have a background. You need to know, the background of AI and all, the architecture based on which it works. So the vectors will be assigned. Okay, vectors are nothing but set of numbers. So those vectors will be assigned to the IDs. Okay, so in embedding, remember, vectors are assigned to the IDs in this process. Once this ID has been assigned with vectors, then it will go to the next process, that is the positional encoding. Positional encoding. In positional encoding, what happens is the positions will be assigned, guys. So whatever input has been given, and then ID has been, so once it is tokenized, the ID has been assigned, then the vectors are provided. So using the vector and the ID, those tokens will be assigned positions. Okay, so that they can be logically placed. So they will be assigned position. So they will be assigned positions using again specialized vectors. Okay, using again specialized vectors. So as part of embedding, we had the combination of vectors plus ID. Then in the positional encoding, to preserve that information, I had told you in serial processing what was happening, that dependency was getting lost. The AI models were unable to track the dependency. But here in transformer architecture, parallel processing is being done. So using all these processes, the objective is to preserve the sequence information, guys. Okay. Now, so they are going to be assigned with vectors and specialized vectors, so that positional encoding will take place. And then once the positional encoding is done, we have the next process, that is self-attention mechanism. Self-attention mechanism. This is very, very important, guys. Once the position encodings have been, now guys, as a human brain, whenever you are asked to analyze any data, right, will you give equal importance to all the data? Anyone? Whenever you are asked to analyze any data, it could be any text, it could be numbers, it could be any data. If you are asked to analyze, will you give equal importance to all the data? Anyone?
No, we can't give equal.
No, right?
Yes.
Yes, we are not going to give equal importance to every data, because we will analyze that and we will be able to know which one needs to be given more importance, right? Now let's say we used to get questions during our school days. There would be a passage, let's say of 100 words. We would be asked to summarize it in 30 words or 40 words, right? Or 50 words. If you have to summarize a text of 100 words into 50 words, you have to choose the important words only. You cannot take everything, right, guys? That is the process here. Self-attention mechanism. So once this positional encoding is done, which all vectors or which all IDs basically or which all tokens need to be given more attention. Need to be given more attention. That is done with the help of this self-attention mechanism. So attention scores will be assigned to the IDs or the tokens. Understood, everyone? The attention scores will be assigned. And then based on that, the AI model can reposition, guys. Okay, reposition, or it can, address that what all things it needs to pay more focus on. Okay, using this self-attention mechanism. So attention scores will be given to the different tokens based on the score. So whoever has the highest score, they will be, given more attention. And in this way, encoder will understand the input. What did I tell you about encoder? The objective or the purpose of encoder is to understand the input. Now, decoder, I have shown only a box, guys. The decoder is again same as encoder. The decoder has again the same components as decoder. Okay, they also have the positional encoding and embedding. So the decoder will generate the output, right? It will generate the output. They also have self-attention mechanism. They also have positional encoding, because I've already explained these processes. The same processes are there in decoder. They will work in the same way. So based on, so whenever it is going to generate the output, it is also going to provide attention scores. It is also going to do positional encoding, but that will happen in the reverse order, guys. From here, what was happening? From the ID, from the tokens, it was going to self-attention mechanism. Then while generating the output, the decoder will go in the reverse method. That is, self-attention mechanism, positional encoding, embedding, and then generate the tokens. So remember, when the input is given or the output is generated, the tokenization process will happen, guys. Your input will be broken down into tokens. Your tokens will then be, generated as output. Understood? So that process happens. So the decoder will also work like the encoder, but in a reverse way. And then you have the output, guys. Okay, then we have the output. So now all the tokens will be generated. So then whatever tokens are generated, those tokens will be, generated as the output. And again, based the user will be able to see the output from the AI model. Clear, everyone? So this is how the transformer architecture works, and the AI models are able to generate the output based on the input given to them. Any queries, anyone? Any queries, anyone? Okay, so then we come to the next one, that is prompts. So we now understand, right, how the output generation happens and when we give the input. Now how to give the input, guys? Okay, so prompt is nothing but it is a set of instructions. Okay, set of instructions which act as the initial input for LLMs. It is the initial input, guys. This is the initial input. It can be instruction or question. Okay, it can be instruction or question. Whatever you ask the LLM to do, that is instruction. So that is the prompt, guys. Okay. So in the prompt, you are basically defining the task, right? You are defining the task. You are defining the task to the AI model, what task it has to do. So in that task, what are you trying to tell? You are providing a context. You are providing the output format, like in what output format you need the data or the output. And if you are looking for a specific outcome, if you are looking for a specific outcome, okay. So that is basically a prompt. Now, do you think anyone can write a prompt, guys? Anyone can write a prompt, right? Like I wrote in the demo session, generate a story on a camel and a whale, or generate an email for applying a sick leave. Anyone can write that. So why are we taking up this training, right? That is the $1,000,000 question, guys. Whatever prompt you provide, you will get the output. But your output, okay, the output of any AI model is a factor of prompt quality. It is a factor of the prompt quality, guys. The output which you are going to get from the AI model will depend on the quality of your prompt, means quality of your input. So if I do not know anything about writing proper prompts, I will not get the desired output. I showed the example. For example, initially when I was trying to generate a summary of the flight attendant, I wrote the prompt as the crew members of an aircraft, right? So in the crew members, the pilot is there, the flight attendant is there, right? So all the other staffs are there. So it generated the entire thing. But my objective was to get the details on flight attendant, right? So that is why then what did I do? I modified that. All of you clear? So over there we saw that the output of a prompt or the output of an AI model will depend on the input which we are providing. That is the quality of the prompt. That is why we need to know the skill set that which is known as prompt engineering, guys. The skill set is known as prompt engineering. So it is an important skill to write effective and accurate prompts. Okay, it is an important skill to write effective and accurate prompts. Are all of you clear?
Yes.
Yes.
So we are going to, as I have told you in the demo session, we are also going to spend time on prompt engineering. Prompt engineering is very, very important to write quality prompts, to write accurate prompts so that you can get your expected output. This skill is very, very important, guys, to converse with the AI models, because by writing proper prompts, you can avoid miscommunication, you can avoid misinterpretation, you can avoid bad context. Understood? So if we know about prompt engineering, we will also be able to write prompts which can avoid security risks, which can avoid cyber threats, which can avoid uh, ethical issues. You can maintain the data confidentiality of your customer. Everything is there, guys. Okay, so we'll see more about prompt engineering. Okay, any queries anyone till now? Any queries anyone? Now, before going to this, I wanted to show you the example of prompt. Can you tell about advantages and disadvantages? Okay, can you tell about advantages and disadvantages of AI? I'm asking an AI model about the advantages and disadvantages of AI. So all of you see, guys, it will generate this output, right? Here, everyone, it will generate this output. You can copy and paste here. Now, if let's say I want to write. So this is what I gave. Can you tell about advantages and disadvantages of AI? I will now tell. Imagine that a company wants to implement, okay, AI in one of its product. Here, explain the advantage of this approach, and then mention about or explain about the disadvantage. Clear, everyone? Now, initially, I only asked about advantage and disadvantage of AI. Now, I'm asking about the advantage and disadvantage about implementing AI in one of the products. So, this is a improved prompt, guys. This is a improved prompt. So, you see, first it is showing automation and efficiency. So, here, efficiency and speed, automation of repetitive tasks. Then personalization, cost savings, improved decision making, and scalability. But here you see, here there was so much of points, but here it focused primarily on the product implementation, AI implementation in the product. So that is where the way you are going to write the prompt, it will determine the output of it. So it is very, very important that we write proper prompts, guys. We write proper prompts. But yes, the LLMs also have limitations. So the different categories of limitations are cognitive constraints, the security risks, and the privacy and legal concerns. Okay, there are limitations of LLMs, and they will be based on cognitive constraints, security risks, and privacy and legal concerns, which we are going to discuss in details in the next session. Are all of you clear? So with this, we'll stop the session for today. Any questions, anyone? Any questions, anyone?
So, when we can expect these materials?
Yeah, these materials will be shared.
Okay.
Yeah.
And how long the YouTube you are sharing recording in YouTube, right? How long it will available in YouTube?
So the recording is available on the very next day. So once team will be in office, so today's recording will be available tomorrow. Okay.
Yeah, I got it. How long it will available? Like
Means I didn't understand
once
the
upload.
question. Yeah, once the videos are uploaded, you will be going to have lifetime access to the videos.
Okay.
Yeah, I think that I had covered in the demo session, but yes, you are going to have lifetime access to the videos.
Okay.
Yeah. Okay. Any other queries? Anyone? Hope you all are enjoying the sessions.
Yes.
Yes, yes.
Very, very good. Okay.
May I know the duration of this course?
The duration of this course is 18 to 20 hours. We'll cover in a month.
Okay.
And about the course, you will be able to find more details in the demo session video. So I'll request you all to please go to, whoever are attending today for the first time, I'll request you to go through the recordings of the demo session as well as the day one, so that you can catch up, okay. I'll probably share the links again for all your reference.
Yes, sir. Sure.
Sure. Okay, any other queries, anyone? So I'll take it as a no. In that case, we'll stop the session for today. Thank you for joining.